Hello physics folk. In today's video we'll be looking at a voltage divider challenge. So here's a breadboard circuit with a voltage divider. The basic circuit for a voltage divider looks like this. Okay, it's pretty much a series circuit where the charge will loop around, and then there's a couple of extra wires for measuring an output voltage across this resistor. Let's go through the components. So Vs is the supply voltage measured in volts, sometimes referred to as the input voltage or the battery. R1 is the first of the resistors, it's measured in ohms. R2 is the second resistor, it's called the output resistor because we're going to measure the output voltage across this resistor. It's also measured in ohms. And Vout is the output voltage found across R2. So we have these couple of wires coming off, and that's typically the circuit that we use for a voltage divider, and that's measured in volts. So the voltage divider equation. The output voltage is equal to the supply voltage multiplied by this fraction, or ratio. And it's actually quite simple. R2, the resistance down the bottom here, divided by R1 plus R2, which is the total resistance, gives us our fraction or ratio. So if this was, say, a quarter of the total resistance, we would get a quarter of the supply voltage. If the ratio of R2 compared to the total resistance was 1/5, we would get 1/5 the supply voltage. It's a very, very simple equation. It's a voltage divider because we are dividing up the supply voltage. We're getting a fraction of the supply voltage representing the output voltage. So example, calculate the output voltage Vout for the circuit shown. We have a supply voltage of 24 volts. We have R1 of 10 ohms. We have R2, the output resistance of 20 ohms. And Vout is our question mark. Our equation, as we just said, Vout equals Vs times the ratio or fraction R2 over the total resistance R1 plus R2. Let's put our numbers in. So supply voltage was 24, R2 was 20, R1 was 10, and R2 was 20. That's going to simplify to Vout equals 24 times 20 over 30. And of course 20 over 30 comes down to 2/3. If I was to divide 24 by 3, I get 8, times it by 2, I get 16. So this particular circuit with 20 ohms on the output resistance and 10 ohms on R1 will give me 2/3 of the original voltage, 24 volts in, 16 volts out, and it works on a simple ratio. If we consider 10 ohms to be 1 unit, this is 2 units out of a total in series of 3 units. So we get 2/3 of the input voltage as Vout. I have now a selection of challenge problems for you to have a go at. First of all, though, I'll give you an example or a sample one. So here you have in front of you a voltage divider circuit, and we've got 12 volts as our supply voltage and 6 volts as our Vout. We've been asked to select R1 and R2 that would give me this output voltage from this supply voltage. So if I were to choose R1 of 10 and R2 of 10, I believe that should give me the right ratio of resistance to get the correct output voltage. So supply voltage is 12 volts, R1 is 10 ohms, R2 is 10 ohms. I want to calculate Vout using this ratio. Let's sub the values in. Supply voltage was 12 volts, R2 is 10 over a total resistance of R1 plus R2 of 20. That will give me Vout equals 12 times 10 over 20, which is effectively a ratio of 1/2. And that will give me, of course, an output voltage of 6. So there's my calculation proof that 10 ohms and 10 ohms for R1 and R2 do in fact generate a 6 volt output from a 12 volt supply voltage. In addition to that calculation, I want to prove this using the PhET simulator that 6 volts is generated in this circuit with 2 10 ohm resistors as R1 and R2 respectively. I've constructed a voltage divider circuit using the PhET simulator. You can see we've got a battery, 2 resistors in series, and then branches coming off that allow us to measure the output voltage over the output resistor. We had a 12 volt supply, and resistor 1 was 10 ohms, resistor 2 was 10 ohms. From a 12 volt in, I expect 6 volts out. Your turn. Challenge A. Select 2 resistors R1 and R2 that will produce an output voltage of 2 volts from a supply voltage of 12 volts. Remember, you need to do a calculation proof and build a PhET simulated proof. Challenge B. Select 2 resistors R1 and R2 that will produce an output voltage of 3 volts from a supply voltage of 12 volts. Challenge C. Select 2 resistors R1 and R2 that will produce an output voltage of 4 volts from a supply voltage of 12 volts. Challenge D. Select R1 and R2, two resistors that will produce an output voltage of 8 volts, given that there's an input supply voltage of 12 volts. Challenge E, select two resistors R1 and R2 that will produce an output voltage of 9 volts from a supply voltage of 12 volts. And finally, challenge F, select two resistors R1 and R2 that will produce an output voltage of 10 volts from a supply voltage of 12 volts. I hope you've enjoyed this video, and I hope you've learned something about how voltage dividers work, how they simply are a ratio of output resistance to the total resistance in a series circuit. If you enjoyed this video, please like, share, comment, and subscribe. And as always, thanks for watching.